Today, we want to introduce a basic concept in process analysis known as Little's Law. This was named after John D. Little, who first explained this relationship back in the 1960s. In order to motivate this, let's consider a setting that we see commonly here at Hopkins, that of the outpatient or walk-in clinic. Each visitor to the clinic has an associated entry time as well as an exit time. In this example, entry and exit can refer to when the patient literally walks into or out of the clinic door. We note that after entry, different patients may see a different number of resources. Some patients only need to visit the front desk, while others need to see the physician, and in other cases need to see additional service providers as well. This means that each patient may have his or her own unique time in the system, as well as his or her own unique sequence of steps. However, for every patient, we know that their exit time minus their entry time equals their flow time, which I write here using the letter T. If we count how many patients are served over some period of time, we have a processing rate, which we can state here in patients per hour, which I will write as R. Similarly, I will always be able to count how many patients exist within the process boundaries. I will refer to this as my inventory, I. What Little's Law tells us is that my average processing rate times the average amount of time spent in the system must equal the average inventory level. This is analogous to a basic relationship from physics that teaches that rate times time equals distance. One famous early text on operations management was named Factory Physics for this very reason. Clearly, if we have this relationship, then we also know that our throughput rate R has to equal our average inventory level I divided by the average flow time T, and similarly that the average flow time T must equal the average inventory level I divided by the average processing rate R. So if I know any two of these elements, I can directly calculate the third. The important things for us to keep in mind about Little's Law are that it applies to any process. Those that are only a single step, those that are sections of a larger process, and those that involve many sub-processes. Note that Little's Law deals with averages, and thus can be said to apply to any system in steady state. By steady state, we mean that the average inflow, the average outflow, and the average throughput rate are all the same. This is important because in most cases it will be easier to measure the inflow or outflow than it is to measure the processing rate directly. Also note that this does not mean that all flow units are the same. Flow times may be different for different paths or different job types. And finally note that Little's Law applies to an average inventory level considered over some reasonable span of time.